In this video I'm going to introduce the concept of square roots. The square root symbol, you may have seen it before, maybe not, looks like that. Sometimes there's a number written right up in here, but usually when you first see them there's not, and I'm not really going to talk about what this number means up in here. This is just an introduction to square roots. Maybe at the end we'll see how it goes, but we want to make sure you're starting off with the basics. Underneath this there will be some number. Let's start, say, with the number 25. All right, what this is asking you is what number times itself is 25. That's the question that the square root is asking you. Sometimes when I write the square root I even think, what times itself? What times itself is 25? Let's see. What times itself is 25? 5 times itself is 25. 5 times 5 is 25. So the answer is just 5 to the question, what times itself is 25? Let's try another one. What if I say to you, did you think it to yourself when I just did that? What times itself? What times itself is 36? You got it? What times itself is 36? 6. Hopefully you're seeing some of these are going to come out nice. I'm picking these numbers so they come out nice, aren't I? Wonder if you could think of one that you could put under here and make it come out nice. I bet you could. Let's try 9. What times itself is 9? That is 3. Alright, let me see if I can trick you now. What times itself is 25 over 36? Don't freak out. It's just a fraction. What times itself is 25 over 36? Your answer's kind of over here. I'm not tricking you too much if you remember how to multiply fractions. Since you multiply fractions by just multiplying the top and multiplying the bottom, you can separate these in your mind and say, well, what times itself is 25? That would be 5. And what times itself is 36? We just talked about it. That would be 6. So 5 6 times itself is 25 over 36. Let's just verify that. Let's check it just to make sure. Check. Let's take 5 6 times itself. 5 6 times 5 6. 5 times 5 is 25. And 6 times 6 is 36. So there you go. What times itself is 25 over 36? 5 6. Let's look at a pattern and see if we can see what kind of numbers here come out so nice, and then talk about what if they don't come out nice. Hopefully you watched a video on exponents, or at least you have an idea about exponents. If you remember your exponents, you'll remember that 1 squared, or 1 to the second power, is 1. That means 1 times 1. 2 squared, or 2 to the second power, is 2 times 2, which is 4. 3 squared, 3 times 3. 4, let's just go down the line. 4 times 4 is 16. 5 squared is 25. Let's go up to 10. 6 squared is 36. 7 squared is 49. 8 squared is 64. I think it's going to fit. Yep. 9 squared is 81. And 10 squared is 100. Now I could keep going when I'm out of space. 11 squared, 121. 12 squared, 144. 13 squared, 169. We could just keep going and going and going. These numbers in this list right here are called perfect squares. This list right here. Perfect squares. And they're called perfect squares because they are some number times itself. And if you watch my other video about squares, that might make a little sense to you, my video about exponents. And it just so happens that if you take the square root of any of these perfect squares, they come out pretty nice. Let's go down the list and try that. So here's my perfect squares. I'm going to start with 1. So I'm going to do the square root of 1. What times itself is 1? Well, that would be 1. What times itself is 4? I'm doing 4 next. What's the square root of 4? That would be 2. What times itself is 9? What times itself is 9? What's the square root of 9? 3. I hope you're seeing this pattern here. What times itself is 16? 4. You know what I'm going to do next, right? What times itself is 25? 5. What times itself is 36? 6. Square root of 49? 7. Square root of 64? 8. Square root of 81? 9. Square root of 100? 10. Now, you should know these. You should know your perfect squares. They help you with your squaring and with your square roots. And it's basically just knowing your multiplication tables. If you've ever looked at a multiplication table chart, these would be right down the diagonal, you know, where you got like 1 times 2 times 3, or 1 across here, and then you got this going on your multiplication chart, you know. Let me do a different color. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, you know what I'm talking about. Your perfect squares are going to go right down. 3 times 3, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and some of you have multiplication tables that go up to like 12 and 20, and I've seen a lot of them. Your perfect squares are right down this diagonal, which makes sense because they're 6 times 6 and 7 times 7 and etc. like that. So if you have a multiplication table and you're using that to help you study, that's where you're going to find your perfect squares. Alright, let's get rid of this. We've got our square roots. I gave you guys an example of a fraction at the beginning. If you know these, you can do a lot of square roots of fractions by just combining these together, like I did that first example of 25 over 36. If I give you the square root of, and then I could pick any of these numbers for the numerator, like 9 over, and then pick another one of these numbers for the denominator, 100. You just do the square root of the top and the square root of the bottom, and that's your answer. Got it figured out before I write it down? It's always good to try to stay one step ahead. Square root of 9 is 3. Square root of 100 is 10. So the square root of 9 over 100 is 3/10. What happens if I ask you a crazy question like this? What is the square root of 50? What times itself is 50? Well, we're looking at this list here, and that's not going to be nice, because 7 times 7 is 49, 8 times 8 is 64, so there's no nice number, in other words, natural number, 1, 2, 3, 4, 5, 6, 7, whole number, that's going to multiply to give 50. We have a couple choices here. We could estimate, or we could bring in the old calculator. Let's estimate first, and then we'll bring in the calculator. The way to estimate is to grab this thing in your mind and figure out where it would go here in this list. Well, square root of 50 would go right in there, wouldn't it? That should be right between 7 and 8. Matter of fact, it's going to be pretty dang close to 7, because 4 to square root of 49 is 7. So the square root of 50 should be just barely bigger than that, maybe 7.1 or something like that. So if you want to get an estimate, we can just bring in the calculator. We can get the decimal. And your square root button is on this calculator right here. Most of your calculators are going to look like that. Now, on this calculator, I have to put the 50 in first, and then I hit the square root button. On a lot of the newer calculators, you hit the square root first and then the number. So I'll go ahead and do it that way. So I hit the square root button, and there's my estimate, 7.07106, blah, blah, blah. Pretty close to 7.1. As a matter of fact, if I had to round it to the nearest tenth, it would be 7.1. And the symbol for approximately is an equal sign that's a little squiggly. It's not exactly equal. 7.1. That means approximately. Let's try one more estimate. See how close we can come. How about the square root of 20? Where's that going to fall? Between what two integers? This is a question you'll see on some standardized tests. Between what two integers is the square root of 20? If it's multiple choice, they might say, okay, is it between 2 and 3? Or is it between 3 and 4? Or is it between 4 and 5? Or is it between 5 and 6? That's a D right there. 5 and. Well, the way you want to do that is just like we did here. You want to take this square root of 20 in your mind and try to figure out, look at your numbers here and figure out where it would fit. Square root of 20 would be right there between square root of 16 and square root of 25. So the answer is going to be between 4 and 5. That would be your correct answer right there, between 4 and 5. Another way you could write it out is you could, if you didn't have this whole list in front of you, let's pretend like we don't have that whole list. I might go over here and I might go square root of 20. I got to think of a number bigger than 20 that has a perfect square. That would be 25. And what's a number less than 20? Like the closest one that's bigger and the closest one that's smaller. And you write those down, and then you write your answers. That'd be 4, that'd be 5, so you know your answer is between 4 and 5. Because you're not always going to have this whole list in front of you. So the estimate should be about, it looks like it's almost halfway between 16 and 25, so I'm going to guess about 4.5. Let's bring in the calculator and see. Clear 20 square root 4.47, so that would round up to 4.5. Excellent. Well, I hope this gave you a good basic on square roots. Remember, it's just asking what times itself. And you can get estimates. You can use your calculator. You can take square roots of decimals too. You can use your calculator to do that. Say I wanted to find the square root of 20.56. Square root is 4.53. You can do that too. And you're going to find that there are actually applications for this when you have to take the square root of something. Probably the first application you're going to see is the Pythagorean theorem, which may sound a little goofy to you right now, but it has to do with triangles, and probably real soon in your math career, if you haven't already, you're going to see the Pythagorean theorem, and you're going to have to use square roots to figure out the answers to those. So this is important, and you're going to want to know how to use a square root. I did tell you at the beginning of the video I might do a different number up here, so if you're done and you want to stop, that's fine. But I'm going to throw in an example of another number just for fun. I just like to do that. Sometime later on in your math career you may see something that looks like a square root, except it has a little number there, like a 3 or a 4 or a 5. All this means is, instead of just what times itself, it means what times itself 3 times is 8. Over here it was like what times itself only twice. What times itself makes 9. You're just doing it twice. 3 times 3 makes 9. What times itself 3 times makes 8. So in other words, I have to think of a number to put in this box. I have to put the same number in this box. I've got 3 boxes because that is a 3. That's how many boxes you want. I got to put some number in this box, the same number in each box, so that if I multiply it, I get 8. Something times something times something gives me 8. Can you think of it? Some of you have already thought of it. That's good. 2 times 2 is 4 times 2 is 8. So the answer to this problem is 2. What times itself 3 times is 8? And the answer is 2. So you could continue this with any number up here. And you could say, what times itself 4 times is 81? And actually that one comes out to be 3. Because 3 times 3 times 3 times 3 is 81. 3 times itself 4 times makes 81. Or in other words, 3 to the 4th power makes 81. These exponents and these square roots are sort of opposites of each other. If you take a number like 3 and square it and get 9, if you want to go back to where you started, you got to square root. Add and subtract are opposites of each other. Multiply and divide, and square root. And then that would continue to, if you take, this is called the cubed root, or if you cube something, so like 2 to the 3rd power is 8, and the cubed root of 8 is 2. This is called the 4th root. 3 to the 4th power is 81. The 4th root of 81 is 3. Now this is actually more, in sort of halfway through an algebra series. So if you're just starting pre-algebra and you're watching this video, don't worry about this. This is just a preview of coming attractions. If you don't completely understand it right now, that's fine. Just plant a little seed in your brain for when it comes up later. But make sure you understand this part with the squares and the square roots. Hope that helped.